In this video, we're going to continue focusing on our preparations for the upcoming exam, and I've pulled a couple examples from our homework number 9 assignment in Math Excel. This first one involves a logistic equation or logistic model. I mentioned in a prior video that a logistic model is one that basically combines both a exponential growth curve as well as a logarithmic curve in order to account for this carrying capacity or this upper limit to the growth model. It could also work in reverse when we're talking about a decay as well. But now instead of racing off towards infinity like a exponential function normally would, instead of racing off upwards like this, it turns and it levels off towards some upper carrying capacity. Now this example is going to create an image that's not quite the same as this, but it does have much of the same characteristics. So let's jump into it. After some analysis, someone determined that this equation, this function, will represent the percentage of households that do not own a personal computer T years since 1983, when the first commercial personal computer really became available. So you could imagine, I would think, that the percentages or the percentage of households that do not own a personal computer now must be very, very small, because virtually everyone does. So let's evaluate and interpret P of 0. Well, the function P of t represents the percent over time, or percent based on time that's passed. So if I were to evaluate P of 0, we should recognize that we're going to take this original function and simply change any t values that we see to the number 0. That's what it means to evaluate. So there shouldn't be any surprises there. Since this question is going to show up on a calculator permitted portion of the test, there's no sense in simplifying any further. I'm just going to rely on you to use your calculator here. Additionally, no more work is necessary, because I'm going to assume that you entered this expression into the calculator as written. Now let's remember that on our TI Inspire calculators, we can get away with essentially writing exactly what we see on paper into the calculator itself. The display features of the TI calculator are really nice for that. So I'm going to create a fraction first by pressing Control Divide, and then off screen I entered the value in the numerator. I'll press the down arrow to jump to the denominator, and I can start entering it. 1 plus e, sorry, that's 0.0441 e raised to the power of 0.2176 times t, and in this case t is 0. When I press enter here, I end up with a result, 91.6707. 91.6707. And that would be a good result for part A. We've now evaluated this expression, 91.6707, although the instructions do say to round to one decimal place, and so we'll call this 91.7, making sure to follow those instructions there. 91.7 seems good. Now, what does that mean? Obtaining a result's good, but we need to understand what the results actually mean. Let's just remind ourselves that this 0 was the t value of 0, so at time 0, and the end result was a percentage. That's kind of what this letter P was chosen for, is to represent a percentage. So at time 0, 91.7% is the result. Now, time 0 is actually the year 1983, 0 years after 1983, and the 91% shows the number or the percentage of households that do not own a personal computer. So of the four options, I like B the best. P0 is the percentage of households without a personal computer in 1983. And so in 1983, that number was pretty high. 91% of households did not own a personal computer. So let's see what happens as time passes. Here are our four options. And we've got to decide which one seems to be the best fit. I think right off the bat we can throw out two of our choices just by interpreting the problem here. Certainly the number of households that do not own a computer would not be increasing over time, right? The number of households that do not own a computer should be decreasing. So I think B and C appear to be the best choices so far. But now we've got to decide on which one appears to be the best fit, which one's the best model. And for that, I would use my graphing calculator to illustrate this. So on my calculator, I'll press Control Dock to create a new page, and we'll add a graphs page this time. In this function bar, I will enter the function that was given to us. And instead of using the letter T in the function itself, I'll have to use the letter X because that's how this TI Inspire is built. And so here we have it. I took the time to build that equation, and again I'm using the letter X because this calculator uses X only as the independent variable. And when I press enter to graph that, well, I don't see the result. And that should make sense. We've got to adjust our scale. Now, we could try to adjust this manually by thinking about the results. I think that would be a good approach, but we can also cheat just a little bit too. You can see that in both of the options that remain, we have an x-axis that runs from 0 to 70 and a y-axis that runs from 0 to 100. So let's go ahead and set our window to match. So we'll choose Menu, Option 4, then Option 1 for window settings. And for x minimum, we'll go from 0 to 70. And I'm pressing the Tab key to jump between these entries. And then on the Y minimums, we'll go from 0 to a Y maximum of 100, and we'll press OK. And here's a graph that's represented, and it does match the same window that we saw before. So to me, it kind of looks like option C is the best choice because we see this bit of a downward turn. We see this downward turn first, and then the graph levels off. In this example over here, we don't see that downward turn. It just seems to be an immediate drop. Now, because this is an immediate drop, we might assume that this is an exponential decay equation, or we might also, if this is truly a graph of a logistic function, we just might not see that downward turn that we're used to for the logistic behavior. It's off the screen. In either case, however, I think C would be the better choice. Now, one other thing I'd like to remind you of and point out is that this particular scale is not one that I'm fond of because, again, the x-axis and the y-axis are right on the edge of the screen. It makes it a little bit hard to interpret. So if it were me building the zoom or changing the zoom, I would go 10% to the left of 0 and 10% to the left of or below 0 on the x and y scales. So since our x maximum is 70, I'm actually going to set the x minimum to -7. And since our y maximum is 100, I'm going to set the y minimum to -10. By doing that, I can see the x, y axes in view, and I can also see just a little bit more of the behavior of the graph. To me, I think this makes the graph a little bit more usable. So now we'd have to interpret some more information. What percentage of households did not own a personal computer in 1994? Well, we don't really have to go back and enter this into the calculator anymore now that we have a graph. We can use the trace feature in order to answer this. But before I do that, let's make sure that we understand that x in this case is equal to 11 because 1994 is 11 years after 1983. When we go to the calculator, if I'd like to find the result at 11, well, it's kind of hard to interpret by looking at this scale. There's not a whole lot of clarity there. However, if we choose the menu option and select number 5 to trace the graph, and then choose number 1, we can move our cursor left and right to different positions of x along the x-axis. But even then, we don't always get very precise positions. So what I'm going to do while my cursor is still active in the trace command is I'm just going to start typing the number 11. This brings up a dialog box that allows us to enter a value for x, and when I press enter, then the cursor will move exactly to position 11, and the y result here does indicate the percentage that we're after, 64.5395. The instructions said to round to one decimal, so 63.5 should be appropriate. And then in part D, in what year will the percentage of households that do not own a personal computer reach 5%? Well, here again, we could use our algebra skills to solve for this. We could set the p-value equal to, we can set this p-value in this equation equal to 5, and then solve for t. So I could say, when does 5 equal the rest of this equation, and then do the algebra necessary to isolate t. Or we could use the graphing calculator. Since 5% is our target, much like one of the examples I showed in the last video, is that I can enter a new equation, f of x equals 5, and this red line represents our target line, and we can now simply look for the intersection of these two graphs. Menu 6, 4 will bring us to the intersection command, and if we select a position below the intersection and above, or to the left and to the right of that point of intersection, the calculator will find the intersection of those two graphs, and evidently that occurs at 27.6 when rounded to the first decimal. So I'm not going to answer with 27.6 or 0.7 when rounded, because the question is not asking how many years after 1983. It asks, in what year will the percentage of the household reach 5%? So we should note that it's 27.7 years after 1983. And 27 years after 1983 would be sometime in the year 2010. And if we're being real specific, we would say towards the end of 2010, because this 0.7 is almost 3/4 of the way through that year. Now, most likely this equation or this model was created sometime in the 80s, if we're referencing, this percentage based on the year 1983. And I don't know that the model is necessarily true anymore, and you might be questioning that as well. Certainly in 2010, which has been 10 years ago now, the number of households without a personal computer would be very, very low. But I almost wonder if there's an uptick in this number now that we're looking at the year 2020. If the percentage of households without the computer dropped, I wonder if it's starting to turn upward again. And the reason why I question that is because of the use of cell phones and tablets and other small devices that essentially operate like a personal computer without the need of the full-fledged device. I don't know if that's really true or not, but it's something that I'm wondering about. It's certainly possible to get by without a computer, considering how much work our phones can do for us these days. Moving on, question number 13, and most of the later questions in the Math Excel assignment, homework 9, involves the fitment of an equation to data. And so I'm looking for very specific results when I ask this question on the test, or when I ask a question like this. I am expecting you to take the data that's provided, this chart over here, and enter it into your calculator, and let the calculator produce the line of best fit, or the equation of best fit for this data. In this particular case, we're using this type of logarithmic function, so the a and the b values must be identified correctly. And we'll all receive the same value, since we're all going to be using the same calculators or most likely are using the same calculators, a TI-based graphing calculator. Additionally, I'm not going to round to whole numbers. Well, for this problem, we'll round to whole numbers because I think that would be appropriate, or to 2 decimal places as indicated. But on the test, my preference is for decimal places. So here we go. Let's first take our data and enter it into the calculator. And so I'm going to create a new page here, and I'm not going to save the last work because I'm done with it now. And if you recall, when we're using a line of best fit, we need to enter the information into a list and spreadsheets page. It is best to describe your columns, so I'm going to describe the top column as quantity, and then the top of the second column as price. So we'll say quantity. Actually, I'm just going to use Q and P for quantity and price. We could use X because I think that's the variable they identified in the first column anyway. And now I'm just going to take the time and enter this data, and I'm going to do that off screen so that you don't have to watch me do that on the video. And again, it's important to remember that when you enter your last piece of information, to check 2 things. Number one, make sure that your X column and your Y column, or in this case Q and P, make sure that they're the same length. If we don't have the same amount of data in each column, then there's going to be a mismatch and we can't move forward. Also, make sure that you press enter after your last data point. If your cursor is still active at the end of this number, then it won't be input and we'll again get that data mismatch. So we'll press enter at the end here. Now that we've copied the data from the table into the calculator, we need to add a new page. So I'll press Control, then Document, and this time we'll add a data and statistics page, either by selecting it from the menu or pressing the number 5 on your keyboard. Then we'll specify the X and Y axis. Along the X axis we have Q, or the quantity that's being demanded. And then along the y-axis we have P, the price that somebody's willing to pay based on the quantity demanded. So I wonder if there's a different inference that's going on here. Normally, as demand increases, then price increases as well. Price is relative to demand. So maybe this quantity demanded more likely represents the amount of, or the number of items that are available. As availability of the item increases, then the value or the price of that item tends to drop. So with 339 machines available, the price is $1,000 a piece, but when there's only 273 available, the price might be that $2,300. So we've got the data in place, we've got it organized now on our data and statistics page. Now we need to find the logarithmic function in this particular format. So if we jump into the menu and select Analyze, option number 4, then Regression number 6, we should be able to identify the equation that fits the best. Now, I'm looking at the options here. We only have one that shows a logarithmic result. So let's see what happens when we choose logarithm. And I somehow ended up with another calculation there. I might have bumped that while I was moving on the screen. So this looks like it's a quartic regression. So let me jump into the analysis and we'll turn off quartic. Yeah, I accidentally turned that on. So we'll hide that one. And now we're back to the logarithmic. If I click on that equation, then we can see the logarithmic result. And this looks pretty good to me because this is the format in which the question in Math Excel is requesting. So on the test, this is nice because I can see 4 decimal places beyond the decimal point, which is what I'm asking for. But in Math Excel, they're only asking for the nearest whole number for value A, and A is this first number in front. So we'll round the 36,299.8 up to 36,300. And for B, which is the coefficient in front of the logarithm, we need 2 decimal places there. And notice that this is a negative number, so a negative 6072.65. The 5 on the right rounds the 4 up to 5 as well. And we've got negative 6072.65. And then moving on, part B says using a graphing utility, graph the data together with the logarithmic function, which we've done. Now we just need to decide which of these options is the best fit or best look. Now I did not see the curve belly like this, or belly up, we sometimes call that, or concave down, depending on your understanding of concavity. The graph tends to, or it seems to have this swell downward. It's not a perfect fit, but it does seem to follow the general shape of the data points there. So I think this option is out. Now it also doesn't look like that this equation's the best fit, or this graph is the best fit, because most of those data points are above the curve. If I look at this here, this curve does seem to go pretty much straight through all of the others. It's a little bit below this first and a little bit above the one in the middle, but it essentially fits right in between all of the other data points. So I don't really like the option for part A either. As we double check option C, which we think is the best answer, it's worth noting the numbers that are surrounding this chart, and this is really trying to emphasize that the x-axis and the y-axis are specified with a scale from 900 to 2400 on the y-axis and 2600 to 260 to 350 on the x-axis. And that's about what we have here too. 260 is right here against the edge of the window. 350 is on the right-hand side. We have about 900 right here to about 2400 on the top of the screen here. So the scale matches, the data matches. I think I like option C the best. Now question C, we've got to be careful with this because we're told to use the function that we've just established, and so I would use the function values that are given to us from the calculator normally, but I think for Math Excel, because of the rounding, we'll use the values that we just established in part A of this question. We also have to be careful too because we're told that the price is $14.50, and the price that's $14.50 is actually the value, oops, went too far there, is the value on the left-hand side of the equation. So price $14.50 is equal to the 36,300 plus, I should say minus 6072.65 times the natural log of x, our quantity. And now that we've got the equation, we can use our algebra skills to solve this. And the more I think about this particular function, the more I realize I should probably spend some time in an economics class because I'm thinking of price as an independent variable. If price goes up, then our demand drops, and that seems to make sense to me. If the price for a computer is really high, then the demand is going to be really low. We're going to be stuck over here towards this left side of the graph. And if the price falls, then our demand will increase. So that makes sense to me when we're describing this curve. But it's interesting that price was placed on our dependent variable axis instead of our independent variable axis. So maybe I'm missing something. And for those of you that have taken economics and perhaps have studied the supply and demand curve, perhaps you can enlighten me or send me a message. Anyway, back to the assignment at hand. Let's go ahead and solve for x. Well, we've already substituted what we know into the equation, and our goal is to get this guy by itself. So what I'm going to do is I'm going to subtract 36,300 to move it to the left, and then I'll divide by negative 6,072. I'm not going to use my calculator until the very last step, so let's just show what the math would have been. 1450 minus 36,300, and that result divided by negative 6,072.65, and that result is equal to the natural log of x. Now, I have no idea what x is. I don't know the natural log of what number would equal this particular fraction, and that's okay, because we should remember that the natural log is a logarithm with a base of e, and if I'm trying to solve for the unknown variable here, then I can rewrite this logarithm as an exponent, and then we can solve for x. So the base of the exponent is the same as the base of the log, and the new power of the exponent is the result of the logarithm that we had from the step before. So we're going to take e and raise it to the power of 1450 minus 36,300 over negative 6,072.65. And the result of that computation should give us our value for x. I don't have a calculator page here, so I'll press Control Doc to add a calculator page. And we'll write the expression e to the power of a fraction. And that fraction, of course, is the same one we've mentioned twice now. So e to this power should give us a result for x. And I did have a typo here because I noticed that this solution is not quite correct. I forgot my negative symbol in front of the 6,000. So we better include that. And now we've got a result. And this one seems to be a bit more appropriate. 310.70. And the result was expected to be rounded to the nearest whole number. And so the 310.7 does round to 311. So evidently, when the price of the computers is $1,450, then the manufacturer can expect to sell 311 computers. It will be important for you to understand how to use the calculators not only for your Math Excel homework, but also for the test that's upcoming in 2 weeks. So please make sure that you have the calculator software downloaded, or make sure that you have a TI calculator available for these types of questions. I believe they started around question 12 or 13 and continued to the end of this particular assignment. If you've got further questions, please let me know. Otherwise, thanks for watching.